This is page 5 of the fault tolerance notes, and section 2.2 is about the synchronization interval. So whether you're using centralized synchronization or distributed synchronization, you need to figure out how often that synchronization should happen. And we have a text reference for this, and it is 13.4.4.1. So the question is how often to synchronize clock I. So to start off, let's assume that clock I, C sub I, is synchronized at t0, so that'll be your baseline. At that time, the value that we read from our clock at t0 minus the real time should ideally be the same, but there may be some error in the synchronization, so we're going to call that delta. So this is our maximum synchronization error. We may not have a perfect process for doing that. So after drifting, so our clock's not going to synchronize continuously, it synchronizes once in a while, so it's going to run for a while, it's going to drift. Then the value that we read from our clock at that time, so C sub I at t minus t, will be bounded by that initial synchronization error plus the rate of drift times the length of the interval, so t minus t0. Now hopefully these two items might, one might be negative, one might be positive and cancel to some extent, but you can't rely on that, so that's the worst case. So t is when to synchronize next. And what we need to ensure is that our clock stays correct or within some absolute error bound. Correctness, which we defined before as C sub I at t minus t, is less than some epsilon. So rephrasing this, what we can say is that delta plus rho times t minus t naught needs to be less than or equal to epsilon. So we can rearrange this so that we have t minus t naught is less than or equal to epsilon minus delta all over rho. And this gives us our maximum synchronization interval. We can make it shorter, but we can't make it longer. And question 2, problem set 7, elaborates on this.